All right, now let's get into solubility and concentration, something you're going to do a lot of. There's three different main types. We're going to go through each one. The first one, over here on the left, is the unsaturated solution. It's a solution containing less dissolved solid than the maximum amount of temperature. These are most of your solutions. And you can always add more to it. So if I add a little bit of syrup to my milk, I stir it up together, that's unsaturated. I can add a little bit more chocolate to it and make it a little bit more chocolatier. A saturated solution, on the other hand, is at the maximum amount. So nothing else can be added into it. If it does, it just kind of falls out of solution and falls to the bottom. So eventually that chocolate milk, if I put more chocolate into it, it's going to go to the bottom and not get mixed in because the milk can't hold it anymore. So no more can be dissolved into theirs. Yeah, the fun ones, which are supersaturated. And the thing you need to know about supersaturation, if you look right at it, you can see crystals. And these only happen at very high temperatures. You increase the temperature, you increase more space for these molecules to dissolve into. The cool thing is once you disturb them, once it cools back down to normal temperature, you'll get some crystals to come out. If you can't read that down there, these are unstable. If disturbed, which means if you tap the glass or add more to it, the excess solid would crystallize out of solution. Those are fun. Once again, that's how they make rock candy, but you gotta superheat it. And the way we know how to do that is, well, yeah, these again. The solubility curves, we'll get back to that, but here's some more. Unsaturated solution, you can keep on adding to it. You eventually become saturated. When it becomes saturated, the solid will continue to fall to the bottom. And supersaturated, if you let it cool and agitate it by adding more to it, it'll just crystallize out. That's another visual way of looking at that. So solubility curves, these are pretty simple, but they show the dependency of the solubility on temperature. So you see the left is solubility in 100 grams of H2O, whereas the bottom is the temperature that you're dissolving it at. So then you have three ways of reading this. Let's take this potassium chloride right here. Let's take this orange line, which I'm going to label blue. Any amount of solid below the line indicates the solution is unsaturated. So everything over here that I'm coloring in blue is unsaturated. Number two, any amount above the line is supersaturated. So all this area up here in green is supersaturated. And three, if the amount is on the lines, so we'll do that one in red, go from orange to blue to red, I'm sorry. Right here, anything on that line is saturated. So you're going to do a whole lot of this, and there's a little math problem for you at the bottom. So now let's do some practice. Which substance maintains the almost constant solubility over the temperature range? So constant means it's going to be the straightest line. And if you look at the green line here for NaCl, that's a pretty straight line. And the straightest line is the most constant, so we'll call that NaCl. So what substance decreases in solubility? Well, if we look at the CaCl2 up here in the top left, that one goes up, so that's increasing. The sodium chloride goes a little bit up, mostly flat, so that one's still increasing. Potassium chloride still going up. Potassium chlorate goes up. But then you have the cesium sulfate down here, which you see the arrow is going down. Line's going down, which means it's decreasing. So it's Ce2SO4. Okay, so that's just basic graph reading. So what is the solubility of potassium chlorate at 60 degrees Celsius? So the first thing you do is you find your 60 degrees Celsius, go up until you see the line for potassium chlorate, which is right here, travel it back over to the left, and there's your answer right there, 20 grams. So if you can read a graph, you can do this fairly simply. Number four, a solution containing 50 grams of calcium chloride is prepared at 10 degrees Celsius. Is it saturated, unsaturated, supersaturated? So you find 50 grams, we'll do this one in blue, 50 grams at 10 degrees Celsius. So 10 degrees, 50 grams, that's right here. We're looking at calcium chloride, which is this line, that is below it. And if the dot is below the line, that is unsaturated. Okay. Number five, a supersaturated solution at 10 degrees Celsius contains 40 grams, blah, blah, blah. What temperature was the solution saturated before cooling to 10 degrees Celsius? Okay, so we got 40 grams at 10 degrees Celsius. We'll do this one in blue again. So here's our dot right here. We're dealing with potassium chloride, which is the orange line. So we see that the dot is above the line, so that's supersaturated. So at what temperature did it need to be to add 40 grams in there? Because the maximum at 10 degrees is 30 grams. So all you do is you trace the dot horizontally back over until it connects with the line, and then you go down, and voila, there's your temperature, 40 degrees. So you just move over until you intercept with the line that you're working with. Number 6, if the saturated solution in the previous question is disturbed, how many grams of KCl will fall out of solution? So remember, we had 40 grams at 10 degrees. At 10 degrees, it's saturated at 30 grams. So you just do the 40 grams, so that's supersaturated solution, minus the saturated portion of it, which is 30, and that gives you 10 grams. You'll get a lot of practice with this in class, but it's really just basically graph reading. That's it.